For today's project, we will be civil engineers to build a house that's able to survive multiple natural disasters. Extreme weather-related natural disasters happen all around us, so we'll try to tackle this problem by building a house that can survive the impacts of earthquakes, extreme wind, and extreme rain. Now that we know what we're making, let's make sure that we have all of our materials ready. For this project, you will need one piece of 8.5 by 4-inch cardboard, 2 pieces of printer paper, 10 plastic straws, 6 small popsicle sticks, 4 large popsicle sticks, 1 gallon plastic bag, which could be the bag that the project came in, 6 small sponge pieces, and 2 balloons. Outside of your project bag, we will also need a blueprint worksheet, a pen or a pencil, tape, and scissors. In addition to these materials, for testing, you will also need a hand fan, which may be provided or you can make one out of a piece of paper, a water bottle, a funnel, and an empty project bin that we can use while testing. Now, once you have all of your materials ready, we can start building our project. Before we get to building, we must create a blueprint for our design. Remember that this is an engineering design challenge, or EDC, so you are free to build any design that you like, and everyone's design should look a little different from yours. Also remember the 3 types of disasters that we're going to be focusing on. Your house will need to survive an earthquake, extreme wind, and extreme rain. To start, I will take my blueprint worksheet, and I'm going to create a house with a lot of vertical supports on the sides. This will help to mitigate the forces of an earthquake. So if I have my base, or a strong foundation, I'm going to have lots of vertical and horizontal supports for the foundation of the house. Then I will also place 4 sponges on the corners of the foundation. This will help to protect against the extreme rain, which will pool at the bottom. And I'll make a sloped roof, which uses our plastic bags to protect the building. This will allow rain to roll off of the roof instead of falling into the house and soaking into the building. Lastly, I will also make sure that the roof of the house uses strong materials in order to keep this rain protection from blowing away in strong wind. I can also label these materials so that it's clear what I will be using. With all of those additions, here is my finished blueprint. When building blueprints with your students, make sure to encourage them to label the materials that they use so that they're being conscious of what materials they're going to be using from the ones that we have to build each of their components for their house. So now that we know what we want our house to look like, we can get to the building. Feel free to follow these steps to recreate my design or take this time to build your own house. First, take your cardboard base and place it onto the desk in front of you. Next, take one of your straws and cut it in half. I can fold it in half like so to approximate the middle, and then make a cut into the straw like so. Then use 2 other straws to make a rectangle about the size of our cardboard sheet. So I'll take 2 more straws and some tape for each of the corners. I personally like to place the tape at a 45-degree angle like this, then place in the straws, and then fold over the tape like so. So when done, you should have a rectangle that looks like this, again, about the size of our cardboard sheet. Then we're going to repeat this step with 3 more straws to make another rectangle that's the exact same as this one. Now we should have 2 rectangles that are the exact same, just like this. And first we're going to tape one of these rectangles onto our cardboard base. So I'm going to line it up. It's about the size of the cardboard base, so we can tape it on however it fits. And we just want to make sure that it is secure enough that it does not move around during our testing. But you don't have to use too much tape for this step. So I'll just connect the 4 corners like this. And then next, we're going to grab 4 more straws, and we're going to tape them to the corners of this rectangle to act as pillars. Make sure to tape them as straight up as possible. So with 4 more straws, like so, the way that I like to tape them is to place some tape, almost like legs, on the straw, just like this, with some little feet that come out. Place it in the corner, and then press the tape down. And you can see we have this pillar that's sticking straight out of one of the corners. And I will now repeat that with 3 more straws on the 3 remaining corners. Now, all of your pillars in the corners should look like this. And to finish off the frame of our house, we're going to take our remaining rectangle that we created and tape it onto the other end of these pillars to create our frame just like this. So I'll get some tape. And for this step, I will attach the top rectangle like so, kind of folding tape over, covering both the top of the pillars that we added and the corners of this frame. Make sure that this is quite sturdy, as we want to make sure that the house moves as little as possible. It doesn't flex too much. So adding some tape like this and then folding it over. Once again, I'll show this one a little clearer. I'm going to add the tape like so onto the straw, place the corner on, and then fold it over onto both the corner and the pillar. Now, you should have a frame for your house which looks just like this. Next, we're going to grab 2 small popsicle sticks, and we're going to tape these together at a right angle to form an L shape just like this. So they can overlap, and then add some tape at a 45-degree angle to them, kind of like this, and fold it over. And we have our shape. And then repeat this 2 more times to get 3 of these shapes. Okay, now that we have our 3 L shapes, we're going to use these to create the frame for our roof. We're going to want to attach one of them on the top of our house on the left side, like so, one on the right side, and one in the middle. And they should go across the 2 beams at the front, just like so. So I will attach that now with some tape. And it might be a little difficult at first, but you kind of want to put the popsicle stick where you want it, and then apply the tape while holding it in place. So I'm going to start at the one end. And then I will secure the stick in the middle. Once you have them secured, feel free to add more tape if you need to make it stronger. But this is what the frame of my roof looks like now. Next, we're going to grab our 4 large popsicle sticks, and I'm going to use these to connect these segments of the roof. So I will use one on basically each side of the roof between the 3 L shapes. So if I get some tape, I'll connect the first popsicle stick, and this will add some rigidity between these popsicle sticks. So I will place one at the bottom on the left side, like so, going across. I'm just placing tape on the back that wraps around the L shape to kind of secure it on like so. Next, I'll place another popsicle stick going between these next 2. And you can see now how it's kind of connecting all of these popsicle sticks together, the L shapes. And then I will do that same thing with the other two large sticks on the opposite side, just like so. And so now you can see that our roof is a little bit stronger, it's more rigid, and there's some more coverage on the top of the roof. Now, as you can tell, our roof still has lots of open space where water will fall into our house and collect. So to finish our roof, we will use our balloons and the provided project bag as materials which are water resistant and will allow the water to run off of the roof. And so for the bag, I can go ahead and just drape it over the top of my house like so. And I'm going to want to place it just like this so that it allows water to run off of both sides. And then I'll go ahead and tape it in place. So I can tape it to the top rectangle from underneath like so to hold it in place. And you can already envision that if we had water from rain pouring onto the top of this house, it would be able to run off of either side along this plastic bag instead of falling into the house through the roof. Don't worry as well if the frame is a little bit flimsy now with all of the weight that we've added to the roof, because we're going to finish that up in one of the next steps. So now I've got my plastic bag protecting the main part of the roof itself. You can also use the provided balloons for a little bit of extra coverage. So I'll go ahead and take one of the balloons and I'm going to cut it open just like so. So I'll insert the scissors and try to cut the balloon. And cutting it open like this now gives me a flat, again, water-resistant material. And I'm going to attach that to the front, and I'll cut my other balloon, and I'll attach it to the back, just so no water falls in through these open ends of my L shape, or the triangle shape of the roof. All right, so as you can see, I've attached the balloons on both sides in order just to add a little bit more protection. You can feel free to add them somewhere else if you need some waterproofing or you think water might get in. You can see that our build is kind of flimsy, however, and there's no walls, so any kind of rain could get in from the sides and damage the inside of our building. And so we're going to want to add walls with some paper, and the paper is a bit larger than the sides of our building, so we're going to cut them down to size, and you'll want to cut them strategically so that we have one sheet able to cover both one of the larger sides and one of the smaller sides. And you can also add lots of tape between these columns and the walls in order to add more structural support that should help with this flimsiness. So I will set this aside for now, grab my scissors, and I'm going to kind of measure just visually where the start and the end of my house is, and mark. Set this aside because it's kind of falling over, and then we will cut out this wall. You can also feel free to decorate this wall with some windows and a door. And feel free to provide materials for your students to decorate this fully if they would like. And then we're going to use some tape, as I mentioned, to attach this to the wall between the vertical columns that we have. So I want this to help increase the stability of my house, and so I'm going to add a decent amount of tape, not too much, but enough to add some support horizontally between the vertical columns. So I'll tape it on. And as you can see, it's already a lot more stable in this direction, and we've got the one side, and then this other piece that we cut off can fit perfectly on this side of the house in order to add stability there. So I will add that on as well in the same way, kind of lining it up. And then I'll hold it in place and I'll add tape from the vertical columns that can secure onto this paper. And this does not have to be precise. Again, we're just trying to get as much coverage as possible. I designed quite a large house, quite a tall house, but you might want to make maybe a shorter house or a smaller building or a different shape. that would allow you to cover more of the surfaces while thinking about how to protect against those 3 types of disasters: the wind, the rain, and earthquake. All right, so now this side is done. I'm gonna just quickly use the last piece of paper to create walls for these 2 parts of the house. All right, so now I've used the last sheet of paper to make walls for all 4 sides. Again, it's not perfect, but I'm just going for general coverage in order to prevent as much rain as possible from getting inside. And lastly, we want to lift up our house off of the ground, because right now our foundation is made of paper and cardboard, and in heavy rain, we might be protected on the roof and the sides, but if water starts pooling around the bottom of our house, it could still seep in. And it's the role of a foundation to also protect against rainwater around the building. And so I'm going to use sponges to lift up our foundation by placing 1 in each of the 4 corners. And this will help to prevent the base from becoming damaged with water collecting. So with some more tape, I'm just going to wrap some tape around the sponge to keep them secured in the corner, kind of like so. And then I will repeat this step with 2 more syringes in the other corners. And then once we're done, our house should be able to stand up and we are ready to move on to testing. Now that we know what we're building, let's test our natural disaster house. So in order to test, we must see how our house performs against each of the natural disasters that we are defending against. So when testing with your students, you could all test the first disaster first, and then the second, and then the third. Or you could have stations set up around the room where students can test each one individually in whatever order they like. And one thing to note is that the extreme rain test might damage the project beyond repair. So if students want to take their projects home at the end of the day, they may want to just skip this test altogether. All right, so first, we're going to start by testing for an earthquake. To do this, simply place your house on a flat surface and then shake the cardboard foundation aggressively while slowly increasing that intensity. Once you have deemed that the house has passed this stage of testing, we can move on to the next one. So I will do that here by just aggressively shaking the house, and we can see it seems like everything's surviving. Nothing has fallen off of it, even if I get more aggressive. So it seems like my house is holding together well. And if something falls along the way, you could encourage your students to take a step back, remember the engineering design process, and improve on their design to protect it from that disaster before moving on to the next one. Next, we will test for extreme wind. Go ahead and grab your provided hand fan. We don't have one here, so we're going to be using this folded piece of paper. And you're going to want to just blow onto the sides of the house and go ahead and rotate it to test each side to see how it performs. So in this case, I'm just going to create some wind, increasing the intensity with my fan, and I'll test each of the sides. I can see the house is moving, but no components are blowing off. None of the walls are coming apart. And so it seems like my house is doing well against the extreme wind. You can challenge your students to create more wind to test their projects, but I've deemed that my house has survived this disaster. So now we can move on to the final test. Finally, we're going to test for extreme rain. So in order to test for extreme rain, you're going to need an empty project bucket. If you have projects that you've already completed, you can just put all of your projects in one bucket and get one that's empty. And then you can also test multiple projects at once, since we can fit more than one house inside of the bucket at a time. And the bucket will allow us to control the mess from the extreme rain, as it will get quite wet. All right, and then what you're going to want to do is take one of the provided water bottles. You can fill it up in a sink or drinking fountain, but we should be able to do it with only one refill of water, as you will see in a moment. But to test, go ahead and open up the bottle and just douse the project in water. You can start light or you can go heavy, and you can go at different angles to see if the house is able to survive. So I'm just going to start dunking water onto my house from different angles. And you can see that the roof is actually effectively pushing all of the water away from the house. So if I lift my house up out of the water, you can see that the walls did get a little bit wet, but they're not soaked all the way through, and the foundation on the inside is actually completely dry. So the roof and the walls did a great job at protecting our house. And if you remember, those sponges on the bottom are lifting the house up right now, and so no water is seeping into the foundation. It's completely protected from the water that's at the bottom of the box. Now, the unique thing with this part of the testing, again, if students want to take their projects home, I would encourage you to have them skip this step as the project will get wet and it might get destroyed. You can go ahead and now dry the project at this time. You can set it outside to dry or fully discard it if the students no longer want it. And then if I move the project out here, what we will do now in order to keep testing is you'll want to take all of the water that's inside of this bucket and take the provided funnel that you're given. And we're just gonna want to funnel slowly and carefully the water back into this cup by just kind of having it come out of the box into the funnel. This will allow you to reuse the water, and it means you don't have to keep going back and forth between a drinking fountain to keep testing. And then you can dry out the box with some paper towels or just leave it a little damp and in order to test with the next students. But if your student's project did fail this level of the testing, you can encourage them to go back, redesign, give them dry materials to start over, and then test again. Now that we're done testing, let's talk about how our natural disaster house works. For this project, we needed to keep in mind all three of the disasters that we wanted to protect against. In the real world, civil engineers have to consider the environment that the house is being built in, but they also need to consider what might change in the future. For example, will it get wetter with more rain? Will there be higher sea levels? Will it get drier and hotter and windier? That all needs to come into consideration for a house to last for a long time. We needed to do this all while minimizing the amount of wasteful materials and while making a cool looking house. In this case, my house design used rubber, plastic, and sponge in areas which would come in contact with water. These surfaces moved the heavy rain away from the house and kept the interior and the foundation safe. I also made my house well supported and wide, allowing it to survive the earthquake and extreme winds. A taller house may have tipped over, while a shorter house may not have been as well supported. If your students wanted to build a taller or a thinner building, they would also need to make different design considerations to protect against these disasters. And in the real world, civil engineers make trade-offs all the time between design, materials, and safety. So in many regions of the world, building codes also determine what materials can be used on what buildings and where. These building codes have developed over time as we have learned more about how to design buildings that are safe and reliable for humans. These building codes add another layer of restriction and guidance which civil engineers must consider when building their buildings. And for example, in California, there are lots of building codes which consider what a building must do in order to survive an earthquake, while in places such as Florida, there's a lot of considerations for maybe hurricanes or extreme rain. Now that we know how our natural disaster house works, there are some questions that you can consider with your students. First of all, what must engineers consider when designing safe buildings? What materials should they use and why? And what was the hardest disaster to pass that we tested on? And what materials would you want to build your house out of if you were to build it in real life?